This is the notes for Chapter 3, Section 2, Part 2, Solving Linear Systems by Elimination. In this section, we'll learn a third way to solve linear systems. This method is called the linear combination method, or addition, because you add the two equations after you create a pair of opposites to eliminate one of the variables. Steps for using this method? Well, you need to arrange the equations with like terms in order. It's best to put it in ax plus by equals c form, the standard form. You want to study the coefficients of x or y, and then you want to decide, do I need to multiply one or both equations by an appropriate number in order to obtain new coefficients for x or y that are opposites of one another. One has to be negative. See, because when we add them, their sum is going to equal 0, and we eliminate that variable. Hence the elimination method. Once you have a pair of opposites, you add the equations and solve for the remaining variable. Now that's going to get you either x or y. You're going to have to back substitute. So substitute the value from step 3 into one of the original equations and solve for the other variable. Remember, with these, you must always check, at the very least on the calculator, like I showed you in class, check the solution in both of the original equations. It's got to work in both, not just one. Now, this example here we have on the front of the notes page is all worked out with explanations given. So let's take a look at it. It says, solve the linear system by using the linear elimination method. Here's my system. 3x minus 5y equals 1. 2x plus 5y equals 9. If you notice, you do have a pair of opposites already. Negative 5 and positive 5 are opposites. The arrangement of the system looks good. They're both in standard form. So I'm going to keep it that way. We're going to arrange the system in columns, lining up those like terms. Here's my x terms, here's my y terms, here's my constants on the other side of the equal sign. Step 2. Multiply the equations by an appropriate number so that when the equations are added, one of the variables will become 0 or no longer exist. Notice here, there is no need for multiplication in this problem because negative 5y and positive 5y are opposites and will add to 0. Step 3. Now I'm going to show, once I have a pair of opposites, I like to circle them, cross them out, and show my plus sign. I've got 3x plus 2x is 5x. This is gone. 1 plus 9 is 10. And when I divide, I see that x is equal to 2. But that's what x is. I have to find y. So step 4. Substitute the value in step 3 into either one of the original equations and solve for the other variable. I chose equation 2. I know x is 2, so I'm going to substitute and replace this x with a 2. That will give me 4 plus 5y equals 9. Subtract the 4, 5y equals 5. And divide. Y equals 1. So now I'm thinking that the solution to my system is the ordered pair 2, 1. Okay, and it's saying that right here. But I have to check into both original equations. Now, I'm showing the work in this. And unless it says to show it on a test or a quiz, you don't have to actually physically write it and show it. but you at least have to do the typing in on the calculator, like something like this. 3 parenthesis for x, pick up the x value is 2, close it, subtract 5 parenthesis for y, substitute the 1 in there, close the parenthesis and hit equals, and you should get 1 equals 1. If you don't, then that means something's wrong. And the same thing, you have to check it into the other equation. So not so terrible. Once you check it and see it works, then we can conclude that the solution to our system is the ordered pair 2, 1. Now remember, all of your answers need to be in ordered pairs. So I want to see that on this homework assignment. All right, ready for side 2, doing the next couple of examples. All right, solve the linear system by using the linear elimination method. Okay, we're using elimination, creating a pair of opposites. I'm looking at my arrangement. The system has both equations already in standard form. Now I have to determine what's the easiest way to get a pair of opposites. Well, I can't make the 2 be a 5 by multiplying it by some integer. And I can't make the 5 become a 2. So going with x would cause me to have to do 2 multiplications. So I'm trying to see if I can get away with 1. Notice over here the y's. This is a positive 3y and this is a negative 1y. Now, yes, their signs are opposites, but their coefficients are not the same. So the opposite of positive 3 would be negative 3. And so I have to multiply equation 2 by a positive 3. Multiply by 3. And it's the whole entire equation that you need to multiply by 3. And the reason we want to do that is because we want the top equation to be 3y and the bottom equation to be a negative 3y, so that this would sum to 0. So I'm going to arrow over, and I'm going to say, well, if I take this equation and multiply it by 3, remember you have to distribute to all of those. This is going to become a 15y minus a 3y equals 33. The top equation, I'm not changing it. 2x plus 3y equals 18. I see my pair of opposites. I like to circle them, cross them out, put my tally bar, and show my addition. Now I'm going to add 2x and 15x to get 17x. I'm going to add 18 and 33. That's going to give me 51. And when I divide, x is 3. Now I'm going to choose one of the equations to find the y. I choose the top equation, 2x plus 3y equals 18. 2 times x is 3 plus 3y equals 18. This is 6, and when I subtract 6 from 18, I get 12. So 3y equals 12. And when I divide, y is 4. Now I'm going to check in both equations. Now remember, what we should be typing in the calculator is this 2 parenthesis for x plus 3 parenthesis for y equals 18. Other equation, 5x minus y equals 11. So I like to set them up. X is 3, y is 4. X is 3, y is 4. You could pick up a calculator. I don't know, this is 6, this is 12. What's 6 plus 12? 18. This is 15, minus 4 is 11. They both work, so now I can conclude that the solution to my system is the ordered pair in parentheses 3, 4. So if you have any questions, please ask in class or post on the discussion. Sometimes it is necessary to multiply both equations by an appropriate number in order to get a variable to sum to 0. Now, if you look at this next example, which is technically example 3, it says solve the linear system by using the linear elimination method. Excuse me. What could I make the 4 and the 6 be? Well, I can make them be 12 and negative 12 if I wanted to. How about the 5y and the negative 2y? Well, the signs are opposites already, and it's not that bad to multiply with 5 and 2. So I think I'm going to eliminate the y's and show that I'm going to multiply equation 2 by 5 and multiply equation 1 by 2. That's going to get me a pair of opposites of 10y and negative 10y. So you've got to make sure that they are opposites. And you also have to make sure that you are multiplying the entire equation, which means you're distributing through all 3 terms. The arrangement's good because I'm in standard form. So multiply by 2. That's going to give me 8x. By 2 is 10y. By 2 is 14. Multiply by 5. That's 30x. That's negative 10y. Remember, I'm multiplying by 5. Negative 18 multiplied with 5 is negative 90. I'm going to circle my opposites, cross them out because they're going to equal 0. Put my tally bar, and now I'm going to add from top to bottom. Please do it this way. Don't be doing some funky moving off to the side. Just keep your equation solving here organized the way I show you how to do it. And this is 38x equals the difference between 90 and 14 is 76, and of course it would be negative. And when I divide, I see that x is negative 2. Now, will they always be integers? No, not always. Sometimes they are fractions. But more often than not, they are integers. All right, I chose equation 1 to back substitute. So I've got a 4. Do I know what x is? Yes. It's negative 2 plus 5y equals 7. This is negative 8, and when I add 8 to both sides, I get 5y equals 15. And then when I divide by 5, I get y is 3. Now remember, I do have to do my checking. Again, it's okay on a test or a quiz. If it doesn't say show the check, you could just type it right into the calculator. Well, I'll do that with you. So I'm going to clear that. 4 parenthesis for x, I'm up here in the system, and x was negative 2, plus 5 parenthesis for y was 3, and I'm going to hit equals, and I see that it's 7. 7 equals 7. Okay, so I did this on the calculator. All right, the next one. Clear that out. And let's do 6 parenthesis for x. X is negative 2. Close it. Subtract 2 parenthesis for y. Y is 3. Close it. I get negative 18. Is that what that equals? Sure does. Negative 18. So negative 18 equals negative 18. Check green light, go. My ordered pair, or the solution to the system, is negative 2, 3. And I circle my answer. Please circle your answers on your homework. Again, if you have any questions, please post a comment on the homework discussion or ask me in class. Sometimes you'll get fractions in, the given system. Just multiply by the denominator in the fraction, the least common denominator. Okay, if they're not the same denominators, then you have to find a common denominator and eliminate those denominators. It makes it so much easier. All right, the last example, which is technically example 4, solve the linear system by using the linear elimination method. Well, I've got to create a pair of opposites. I think this time I'm going to try to make the x's opposites. Notice that all of the signs are positive. So I'm going to have to multiply by a negative somewhere to get a positive and a negative thing going on. Well, I could multiply the top equation. Again, I said I'm going to get rid of the x's this time. So I have to make the 3 and the 2 become 6's. I want a positive 6x and a negative 6x to create a pair of opposites for myself. So I'm going to choose to multiply equation 1 by a negative 2. And I'm going to multiply equation 2 by positive 3, right? Because that's going to give me negative 6x. This is going to give me positive 6x. Now remember, you have to distribute. It's got to be to all terms. If you miss one, it's going to mess up your whole deal. So you might want to put parentheses around it so that you remember. So I got 3 times 2 is 6. It's negative minus 4y equals negative 20. And positive 6x. 5 times 3 is 15. It's positive. Equals 3 times 3 is positive 9. Here's my opposites. Circle them, cross them out. Put your tally bar down and show what you're going to add. When I add negative 4y with 15y, I get 11y equals, the difference between 20 and 9 is 11. It's negative. And when I divide, y is negative 1. But remember, I have to find the ordered pair, so that means I have to get x. I chose, again, to use the top equation. 3 times x, because I don't know what x is, I found y this time, plus 2 times y is negative 1, equals 10. This is negative 2, and when I add it to the other side, I get 3x equals 12. Divide, x is 4. Now be careful when it's backwards like this. You know, my ordered pair is 4, negative 1. Okay, not negative 1, 4. So be cognizant of that. My check, my second check, I'm going to just show 3x plus 2y. Notice I'm leaving parenthesis placeholders. It's so much easier. 2x plus 5y equals 3. Alright, what's my x? My x is 4. And 4. My y is negative 1. And here I've got 12 minus 2 is 10. It works. Here I've got 8 minus 5 is 3. It works. And so now I can be sure that the solution to my system is 4, negative 1. Okay? I don't think they're too terrible. But again, if you have any questions, please ask in class or post a question on the homework discussion. Have a great day.